Hi, welcome back. This is the second part of the limiting reactants video. So if you got the concept down, great. If you don't and you need a little bit more extra practice, I've got 3 more practice problems here for you to look at and see exactly what's going on. So here's an example from biology where we're working with carbon dioxide and water, and we're producing glucose and oxygen. So first thing we're going to do is start with our balanced equation. So we're starting out with carbon dioxide here and our water, and that's going to form glucose and oxygen. And of course, we need to have our balanced equation. So we've got our coefficients that we're going to add here to get this equation balanced. All right, they're telling us that we're starting out with 88 grams of carbon dioxide, and the molar mass for carbon dioxide is 44. So if we take 88 and divide by 44, that gives us 2 moles. Here we have 64 grams of water. If we divide that by 18, that is going to give us the moles of water, and that ends up being 3.56 moles. All right, so if we divide these out, we're going to take them up. We're going to make our 2 clouds up here. So here is our first cloud. We're going to take 3.56. We're going to divide that by 6. We get 0.593. Down here, we're going to take 2 divided by 6, and that is 0.33. So that is our smaller cloud. Over here, we're going to erase this cloud and get rid of it, because we're not going to use that for our calculations. And then we're going to proceed from there. So here we're going to use up all 2.0. Over here, we're going to subtract 2.0 from this. That means that we have nothing left here. And here we're going to end up with 1.56. Over here, we're going to produce 0.33 mole. Oh, I'm sorry, this is our before column. I apologize about that. Let's change that. We are going to end up starting with none of these. We're going to form 0.33 because we took our 0.33 and we multiplied it by our 1. And then over here, we're going to form 2 moles of oxygen gas. So finish out our columns here, and then we can do our calculations. Go. All right. So now we can determine that our limiting reactant was CO2. We're going to figure out the excess reactant, that is our water, and how much of that is in excess. We're going to take this, we're going to multiply it by 18.0, which is the molar mass of water. And when we do that, we end up with 28.1 grams. So that is our answer to here. It's water. And we're going to have an extra 28.1 grams. Formed. Then they wanted to figure out the mass of the glucose. So we're going to take this, we're going to multiply it by the molar mass of glucose, which is 180. And when we do that, we end up with 59.4 grams of glucose. And that is the answer to that question. Next question we have deals with ammonium nitrate and sodium phosphate, and they want to figure out which one is the limiting reactant, what is the maximum amount of each product formed. So we got to figure out the mass of each of those products, then how much the limiting reactant is going to be left over. And we're starting out with 30 grams of ammonium nitrate and 50 grams of sodium phosphate. So I'm going to put our equation in here. They have nicely already balanced that for us. All right, then we're going to take our grams and turn them into moles. So this guy I need to divide by his molar mass. And the molar mass for sodium nitrate is 80. So I'm going to take 30 divided by 80. and that's going to give me 0.375 moles. Then my sodium phosphate, I need to take that 50 grams. I need to divide that by its molar mass, which is 164. So when I divide that 50 by 164, I end up with 0.305. All right, then I need to create my clouds. So I'm going to take my sodium, my ammonium nitrate. I'm going to take this, I'm going to divide it by 3 when I bring it up into the cloud. So that ends up being 0.125. And then here I divide that by 1, I end up with 0.305. All right, so this is the bigger number. This is a smaller number. We're going to get rid of the bigger one. It's gone. Then we're going to multiply throughout everything. So this gets multiplied by 1, so that's 0.125. So we're going to use up 0.125 moles of that. We're going to use up 0.375 moles of this. Over here, we didn't start with either of these. This one, we're going to take this, multiply by 1, which is 0.125. So we're going to form 0.125 moles. And then over here, we're going to multiply by 3, which means that we're going to produce 0.375 moles of our sodium nitrate. This is 0, and then if we subtract 0.305, if we subtract 0.125 from that, we end up with 0.18. All right, so that's how many moles excess we're going to end up with this. Then we need to multiply these by their molar masses. So for this guy, I'm going to multiply it by the molar mass for sodium phosphate, and that's times 164. And that means that for my sodium phosphate, I'm going to end up with 29.5 grams left over. Over here, I need to multiply this by its molar mass, which is 149. So that means that I'm going to end up with 18.6 grams produced. And over here, I'm going to end up multiplying this by its molar mass, which is 85. And so I'm going to take the 0.375, I'm going to multiply by the molar mass of sodium nitrate, which is 85, and that ends up producing 31.9, oops, I have the wrong, 31.9 grams of the sodium nitrate. So if we're looking up here, they wanted to know which reagent was our limiting reagent, and our limiting reagent then ended up being our NaNH 4N. NH4NO3. They wanted to know the maximum of each product form. So for this guy, we ended up with 18.6 grams of our ammonium phosphate. And for our sodium nitrate, we ended up with 31.9 grams. And then they wanted to know, assume how much of the other reagent is left over after the reactant is complete. Well, that excess reactant was sodium phosphate, and we ended up with 29.5 grams of that left over. All right, and then for our last problem, we have calcium carbonate and iron phosphate reacting together. So we're going to put our balanced equation here. And again, they nicely gave us the equation already balanced out. All right, so we're starting out with 100 grams of our calcium carbonate. We're going to divide that by the molar mass of calcium carbonate. And the molar mass for calcium carbonate is 100.1. So we're going to divide this by 100.1, which means that we have 1 mole. We have 1 mole of this. Over here, we have our iron 3 phosphate. Our iron 3 phosphate here, we ended up having 45 grams of that. So we're going to divide that by 150.8, which is the molar mass for iron phosphate. And when we do that, we end up with 0.298 moles. And you can probably go ahead and without even figuring out the cloud, you can see that this divided by 2 is going to be way less than this divided by 3. But if we do 1 divided by 3, we end up with 0.33. And then over here, if we take this and divide it by 2, we're going to end up with 0.149. All right, that means that this is our smaller cloud. So we're going to get rid of this guy. And this is the cloud that we're left with. That means that we're going to multiply everything through with that cloud value. So here we end up with 0.149. I'm sorry, this is our starting amount. That would be 0. So this is 0 and, oh, it's driving me nuts. This is 0 and this is 0. And that means that we're going to use 0.149. And over here, we're using 0.1. Over here, we're going to take this value and multiply by 2, which is 0.298. And over here, we're multiplying it by 3, which is 0.448. So here, this is how much we're using. So we're going to subtract those. This is 0. Here, we end up with 0.552. And these are 0.149. All right, so they wanted to know which one is our limiting reactant. That's going to be our iron 3 phosphate. What is the maximum of each product form? If we wanted to do it as moles, these would be the mole values. If they wanted mass, then we're going to multiply these by their molar mass. For calcium phosphate, that's going to end up getting multiplied by 220.3. And that's going to mean that we are going to produce 32.9 grams of calcium phosphate, and our molar mass for iron 3 carbonate, is 235.8. So that means that we are going to produce 35.2 grams of our iron 3 carbonate. Over here, they wanted to know how much of it is left over after the reaction is complete. So we're going to take this, multiply it by its molar mass, which is 100.1. And when we do that, we end up with 55.3 grams. And that's your final answer.